we are going to talk about how to solve these systems algebraically, which means we're actually going to do a bunch of math. Some of the problems are going to be easier than others. I'm going to shorten your homework assignment a little bit, so you kind of get some liberty there to decide some things. And we're going to be using the idea of substitution. So, what does it mean to substitute? Yeah, so to replace something with something else, to put something in its place. So when we're substituting, we are always looking for an equation, and one of our equations has to be, so one of our equations has to be in either x equals or y equals form. One of those two things has to be true. One of our equations has to be in x equals or y equals form. It doesn't matter which one. We're going to talk about which one is the better option for you, because we always want to make our life a little bit easier if we can. So we're going to talk about what the better choices are. But sometimes, like in the problem that we're looking at right now, it's given to you in that format. So notice that my first equation here is in y equals form. And it tells me that y equals 1/4 x minus 3. So that means if this y equals 1/4 x minus 3, then this y also equals 1/4 x minus 3. So we can substitute. So you're going to take up most of the space on this page writing this problem out. I'm just letting you know, like we're doing this whole problem on this page. So don't worry about like whatever space you need to take up, feel free to utilize that. So if I'm substituting this, I have the equation y equals, I'm sorry, let me write that again. I have the equation 3x minus 2y, but instead of y, what are we going to write? Times x minus 3 squared equals 13. And I am going to be very intentional about my color coding today. Because this is one of those things that it helps a lot to see the colors to connect things. So all I have done right now is for y, I have substituted 1/4 times x minus 3 squared. We can do that. We are allowed to do that. So now we're going to do some math and actually work this out. This is a pretty ugly looking problem. So what are we going to have to do? Yes, I have to make it not ugly. And how do we make that happen? Distribute. What am I going to distribute? The -2. If I'm to distribute the -2, what am I distributing it to?
The 1/4.
Just the 1/4?
Yes.
You think and the x minus 3? Okay. So stop writing for a second, and I'm going to ask you a different question. Totally unrelated, but it will make sense in a second what I'm doing, I promise. So if I have 2 times 4 times 3. This is essentially the same problem. It's just got all numbers instead of letters in there. So the question is, do I multiply the 2 times 4 and the 2 times 3?
No.
Why not? Because it's two different parentheses? Okay. So let's work this out mathematically. Like if I'm multiplying 2 times 4 times 3, what should I multiply first?
4 to 3.
Okay, what is 4 times 3? 12. And then I'm supposed to multiply, so I multiplied these two pieces together. And then I need to multiply that by 2. And I get an answer of 24. If I had gone ahead and distributed this 2 in, which was the question of is that what we should do? If I had done that, which is not correct, and I'm going to explain why, that would have given me 2 times 4, which is 8, times 2 times 3, which is 6. What is 8 times 6? 48. So you can see how distributing this 2 in would not give us the correct answer of 24. It would give us a wrong answer of 48. So the question is, how does that apply to this problem? So, okay, could I distribute the 1/4? Well, let me ask this, can I distribute that 1/4? Can I distribute this 1/4 to the x minus 3 that is squared? I have to unsquare it first. So let's do that first. That'll be a lot easier. So let's unsquare this first. So that means 3x minus 2 times 1/4. If I'm going to unsquare x minus 3 squared, what does that mean I need to do? I need to multiply it by itself. So it really becomes x minus 3 times x minus 3. How do I multiply x minus 3 times x minus 3? Distributive property, or I FOIL it. So if I'm going to FOIL this, so we have 3x minus 2 times 1/4. And now I'm going to FOIL FOIL. The F stands for first, so x times x is x squared. First outside is negative 3x. First outside inside would be negative 3 times x, which is, and then, oops, sorry, I didn't mean to do that color. So negative 3x. And then last negative 3 times negative 3 would be positive 9 equals 13. Okay. Now what should I do?
1/4.
Multiply the 1/4? Okay. Any other thoughts on what we could do? Okay. Do you think it matters which one we do first? It doesn't, because you're going to end up doing the same amount of math. I'm going to hold off on the 1/4 because I want to do something else with it in just a second and talk about what we're doing, and we're going to make our lives a little bit easier. Because anytime we can make our lives a little bit easier and do a little bit less math, we're going to be happier people. Because we don't like doing, well, y'all don't like doing math anyways. Let's be honest. I love doing math. So I'm going to combine my like terms. So I end up with x squared minus 6x plus 9. And the reason I get that is because I took my negative 3x and my negative 3x and put them together and got a negative 6x. And this problem still equals 13. So the next thought is I need to distribute the 1/4. I'm not going to say that's wrong. That is not a wrong idea. That is a correct idea. But if I distribute the 1/4, what else am I going to have to distribute in a minute? The 2. So I can save myself time and a little bit of work by distributing the negative 2 to the 1/4 first. When we multiply, going back to this problem we looked at a second ago, if I had, same problem, so 2 times 4 times 3, if I had first multiplied 2 times 4, what is that going to give me? 8. And then I had multiplied 8 by 3, what am I going to get?
24.
So it doesn't matter what order I multiply in as long as I do all of my multiplication correctly. Now, if I do my math wrong, that's going to give me the wrong answer regardless. But it doesn't matter what order I multiply in. So what that means is that when I'm multiplying, I could multiply 2 times 4 first, or I could multiply 4 times 3 first. That is the associative property, commutative property, one of the two. I don't remember. Sorry, I'm really bad with those names because apparently they are really important properties to memorize. But what that means is that I was being sarcastic, by the way. That means I can multiply the negative 2 times the 1/4 first. And that's going to help me out because it's going to just make a little bit less work than I end up having to do. What is negative 2 times 1/4? So negative 1/2 times x squared minus 6x plus 9 equals 13. Please hear me say it would not be wrong if you distributed that 1/4 first. You could multiply 1/4 times x squared, 1/4 times negative 6x, 1/4 times 9, but then you would also have to multiply negative 2 times that, negative 2 times negative 6x, negative 2 times that after you distributed that first time. So you would just end up distributing twice. Whereas now we multiplied these two and now we only have to distribute one time. So again, just saving ourselves a little bit of work. You can do that with whole numbers. So now I have 3x, and then what do I do with that negative 1/2? Distribute it. I multiply it. So negative 3, or so 3x, I'm sorry. And then negative 1/2 times x squared would be negative 1/2 x squared. Negative 1/2 times the negative 6x would be a positive 3x. Negative 1 times 9 would be negative 4.5 or negative 9 over 2. Either one. That is a pretty decimal. And it equals 13. All right, what should I do now? This is looking so much better than it started with. Combine like terms. What are my like terms that I can combine? The 3x and the 3x. And when I combine those, I get 6x. So I still have my negative 1/2 x squared plus 6x minus 9 over 2 equals 13. All right, what else can I do?
Subtract 13.
Okay, so I need to move either the negative 9 over 2 or the negative 4.5, or I need to move the 13, one or the other. Let's move the 13, because anytime we can get these problems to equal 0, it's going to be a lot better for us. So I'm going to minus 13 from both sides. So I have negative 1/2 x squared plus 6x, negative 9 over 2 minus 13,
Negative 17.5.
negative 35 over 2.
Yeah.
Okay.
Yeah.
And then it now equals what?
0.
Yes. And if I have a problem that equals 0, what can I do with that?
Quadratic formula.
Quadratic formula. It's a quadratic equation. I know, right? All right, so now we're going to use quadratic formula to solve this. So in case you've forgotten what the quadratic formula is, I'm going to write it out for you. Negative b plus or minus the square root of b squared minus 4ac all over 2a. You should never have to memorize the quadratic formula. If I don't give it to you, it's because I forgot. Just say, hey, Miss Krim, what is this? Okay, because sometimes I forget that you need that, because I know it by heart, so like I don't think about the fact that I need to tell y'all sometimes. So if it's ever like on a test or a quiz and you need that, let me know. Just like, Miss Krim, you didn't give this to us. Oh, you're right, I'm sorry, here it is. I'll always give it to you. So I just need to plug in my number. So what is that? Negative b is really negative 6, and then we have plus or minus the square root of b squared, so 6 squared, minus 4 times a, which is negative 1/2, times c, which was negative 35 over 2, or negative 17.5. And then all of this is over 2 times negative 1/2. Okay, and when we go to put this in the calculator, which part of this do we do first in the calculator? Inside the quadratic form, inside the square root symbol, that piece is called our what? The discriminant. So we're going to put all of this in the calculator first and get a number for that. Don't put the square root symbol in all of that part. And it's going to give you something nice, doesn't it? It gives you 1. Isn't that so exciting? All this work to give you something pretty like 1. So negative 6 plus or minus the square root of 1 all over, what about the denominator? I have 2 times negative 1/2. That is negative 1. Okay, can I take the square root of negative 1? Or I'm sorry, I asked the wrong question. And you answered the question I wasn't asking, so thank you for not listening to me. Can you take the square root of positive 1?
Yes.
That was the question I meant to ask. You can. So this problem is going to work out really nice. It's going to give us good numbers, and we like it when it gives us whole numbers. We don't like it when we have to leave it as something awful. We want good stuff. So anytime we can take the square root, this problem is really negative 6 plus or minus 1 divided by negative 1. Because the square root of 1 was 1. So when I take the square root, remember that square root symbol is no longer there. So now, because it's all numbers, I can actually write this as 2 things. I can write this as, the first one would be negative 6 plus 1 divided by negative 1. And I can also write it as negative 6 minus 1 divided by negative 1. So I can work this out into really 2 separate problems. And then I just need to do some math. Okay, so on the top, negative 6 plus 1. What is that going to give me? Negative 5. So I have negative 5 divided by negative 1, which is 5. Okay? And then what about negative 6 minus 1? Negative 7 divided by negative 1, which is... Are we done with our problem? What have we found?
Zeros.
We found for the parabola or the quadratic equation we ended up with, which was this one, this long formula, we have found our roots of that problem. What we have found in relation to the original problem, though. Okay, so here was my original problem. What is this? It has how many equations? 2. That makes it a System of equations. So what am I looking for when I have a system of equations? The answer, which is where they intersect. How many intersections does this system have? 2, because we ended up with how many answers? 2. Now, do I have my entire answer? Which half do I have, the x half or the y half? We have the x half of our answer. And the reason we know we have the x half was because in our equation that we did in the quadratic formula, what variable was in that equation? X. So what this means is I have 2 things. I have 2 ordered pairs. This graph is going to intersect at 2 places. And I know that one of my x values is 5 and the other x value is 7. That's what we have figured out at this point. A lot of work to get to that. Like, I acknowledge, it's a ton of work. And it's like almost ridiculous how much work we've had to do.
Wait, so the x value for the intersections would be at 5 and 7.
The x values for the intersections are at 5 and 7. So now what do we have to do? Find the y values. Well, let's go back and look at our equation. They're not 0 because what we had to do was we had to set this equation equal to 0 so we could solve it. So that means we've taken our graph and we've done a bunch of stuff and moved it around, and we've ended up looking at where it crosses the x-axis now. But that is not going to give us our answers to where it intersected, because we need to go back to our original problem. So look at that. It was a good question though. So look at my 2 equations. How am I going to figure out what y is from these? I'm going to plug in the x. Should I plug it into the first one or the second one? No, the second. This is so much easier. This is so much easier. I promise. I promise. So my first equation was y equals 1/4 times x minus 3 squared. But we already know what x is. What was our first x value? 5. So we're going to plug in 5 for x. So instead of being 1/4 times x minus 3, it's going to be 1/4 times 5 minus 3 squared. Well, what is 5 minus 3? 2. So really this is 1/4 times 2 squared. What is 2 squared? 4, and 1/4 times 4 is 1. Okay, so that means my first ordered pair is the ordered pair 5, 1.
Correct. So now we're going to plug in 7?
Yes, ma'am. Now we're going to plug in 7. So same process. We're just going to use our 7 for our x value here. So same equation, 1/4 times x, but instead of x, we're going to use 7. Minus 3 squared. Well, what is 7 minus 3? 4. And 4 squared? 16. What is 1/4 times 16? 4. So my second ordered pair is 7, 4. So problem 6, one of the things we said was that in order to do this, one of your equations has to be in x equals or y equals form. So is either one of our equations set up like that? So that means we're going to have to manipulate one of our 2 equations. My recommendation is, number 1, solve for something that has a coefficient of 1, because that means you're not going to have to divide by anything, so you're not going to end up with more fractions than you may potentially be given. My second piece of advice would be to never solve for the variable that's squared. It actually makes your life a lot easier if you do that. So what variable is squared in this problem? The y. So we're not going to solve for y. So we're looking for something that has a coefficient of 1. So in our first equation, let's solve for x. Okay? So how do I solve this first equation for x? Yes, dear.
Okay, so we don't. It makes it easier to not solve the squared one.
It makes it to not solve for the squared variable. So what I mean by that is y is squared, so don't solve for y in this problem.
But they both have to equal either x or y.
Either one of them has to equal x or y.
Oh, it doesn't have to be.
It doesn't have to be the same. So I can solve the first one for x. I can use that first equation. I'm not saying don't use that first equation. I'm saying don't solve for the squared variable. Don't solve for y. Okay, because in a second, we're going to work about halfway through this, and I'm going to let you guys finish the work on this one. And when I do that, I'm going to show you what would happen if you did solve for y. So that way you can end up seeing and you can compare and be like, oh, you're right, I really shouldn't do that, and this is why. So let's solve for x in that first equation. So to do that, I need to get rid of the 6. So I'm going to add 6 to both sides. So my new equation that I end up with, and I'm going to write this down below, is x equals negative 1/6 y squared plus 6. So now that I have my first equation resolved, then I know that because I have x here and I have x here, I can substitute this equation in for x. Okay? I can substitute that equation in for x. So I'm going to replace this. It's going to become 2. And then instead of x, I'm going to put negative 1/6 y squared plus 6 equals 6. No, sorry, I forgot something. Plus y. I apologize.
We wouldn't solve it for, like, make that equation into y equals?
No, we're not going to. We're not going to do that. So we're only solving one of them. Yes, ma'am.
Could you change it into y equals before you did it?
You could, but I wouldn't.
Does it make it harder?
Yeah, in this particular problem it would, because we now have 2 y's in our problem that we're having to work with. And so if you put it in y equals, then your y's are on separate sides, and we really need them on the same side. So for what we're doing. So what do I do now?
Subtract that. Oh, wait, you can just change
You multiply.
Okay.
Oh, yeah. You get
Yeah.
unsquare it.
Do I have to unsquare it this time? Because the squared is only attached to what? The y. It's not attached to something like it was before, like x minus 3. So I'm not going to have to FOIL this time. So we save ourselves some work, which is why we solved for the variable we solved for. So we distribute. So we're going to multiply the 2 times negative 1/6, which would be negative 1/3 y squared. And 2 times 6 would be 12. And then I have my plus y equals 6. Okay, what do I need to do now? I need to subtract the 6 because I need to get these all on the same side. So I'm going to minus 6 from both sides. So I end up with negative 1/3 y squared plus 6 plus y equals 0.
Are you allowed to move them, like just put the y in the middle?
Yes, we can rearrange stuff as long as we keep the signs attached to them. So remember, your sign that's attached to a variable or a term is the number in front, is a sign in front of it. So I could rewrite this, and that was the question, was I can rewrite this as negative 1/3 y squared plus y plus 6 equals 0. So I can't just solve for a variable because I have y squared and a y. I can't combine them together because one is y squared and one is y. They are not like terms. But what can I use on this problem now? I can use the quadratic formula. So we can do that at this point. So do you see how much less work this problem required? It's way better. I'm going to let you guys go ahead and work through the quadratic formula. And what I'm going to do while you're doing that is I'm going to work through and solve it as if we'd done it a different way. And then we can talk about why the way we did it as a class is a better option.
Okay.